Hello friends, today we are going to solve trapping rainwater problem from Leet Code. So this is one of the famous problems from Leet Code and it is being asked frequently in interviews. And it could be asked directly or it could be a flavor of this. So let's get to the problem. Trapping rainwater. So here I have drawn a bar graph with the bars as the elevation of the area, and then we are going to find out how much water can be trapped in these areas. So I have represented the water with blue color, and if you see, we can store one block of water here, and then 2, 3, 4, 5, and then 6. So we can store totally 6 blocks of water. So let's see what we can do to find out the solution for this problem. I have 3 types of solution for this problem. The first one is going to be a naive solution where the time complexity is going to be O of n square and space complexity is going to be constant O of 1. And in my second solution, we are going to have a time complexity of O of n and space complexity of O of n as well. In my third solution, we are going to have time complexity as O of n and the space complexity is going to be constant O of 1. So that is going to be our best solution. So I would save it for the last. So let's see our first solution. What we can do to find out the blocks of water. So the simplest solution would be is to iterate over the blocks and then figure out whether we would be able to store water in that block or not. So to figure out that, we are iterating to the first element now, and then we are going to find out the maximum elevation from the left side and the maximum elevation from the right side so that we can see whether the water can be trapped in between. So when we iterate over the blocks, the first block is this one and it has a height of 1, and the left max is nothing but 1 because this is the first one, and in the right side the highest one is going to be 3. So between this we have to find the minimum height. So 1 and 3, the minimum is going to be 1, and then the current block is also 1. So if we subtract 1 minus 1, then it is 0, so we won't be able to store water here. So let's iterate to the second block. Here we have already found out that the left max is 1 and the right max is 3, and now if we find out the minimum of it, it is going to be 1. So 1, and then if we look at the current block, the elevation is actually 0. So since the elevation is 0, so let's look at the previous one. So here this would make it even easier. So here if you see, the height is 0 and 1 minus 0 is going to be 1, which means that we can store 1 block of water here. Similarly, we are going to continue with this for the remaining blocks and then going to find out the content of water that can be trapped. So let's get to the implementation part now. Here I have pasted the content from the Leet Code where they have described the problem and they have given us an example input and output. So let's start with our solution. So define trap height. So height is going to be given us, which we are going to iterate over. So let's store blocks of water in this variable. I'm going to initialize it to 0, and then now we are going to have a for loop where we are going to iterate over each block for I in range of 1 comma length of height. And then here I'm gonna first find out the left max, and then I'm going to initialize the left max is the current value of the array, and then we are going to iterate over the array here. So let's write a comment here. So iterate from beginning of the array to the current element to find the left max. So for I, not I. So let's have a different variable for j in range of I. Left max is equal to max of left max comma height of j. Now we found out the left max of, and then now we are going to find out the right max. For that we are going to iterate from the current element to the end of the array for j in range of I plus 1 comma length of height. Right max is equal to max of right max comma height of j. Let's initialize the right max the way that we did for the left max with the current element. So now since we found out the left max and right max, now we need to find out the minimum of those two values and then subtract the current element to find out whether a block of water can be stored or not. So block of water is equal to block of water plus minimum of left max comma right max, and then we are going to subtract the current element. So we can have this in parentheses to make more sense, and then we are going to return blocks of water. So let's call the with the input given from the Leet code, and then I'm going to have a print statement on this so that we would know what is the result that is being returned. And then I'm going to run this solution, and the answer is 6, which is the expected output. So our solution works good. That's cool. As I told before, the time complexity of this solution is going to be n square, as there are 2 for loops which are nested. So now let's move on to the second solution. So how we can make this one better, maybe by passing through only once rather than doing the passing twice. So for that we need some kind of storage to store the max values. So in our first problem, the actual problem was we are iterating over the beginning of the array to the current element to figure out the left max, and then we are finding out the right max by iterating over the current element to the end of the array. So this added more time complexity. So how this can be eliminated is by storing the left max and right max before starting off the iteration. So let's see how we can store this left max and right max. Let's edit this solution. So we are going to iterate over the elements here, and then we are going to find out the left max here. So instead of that, let's copy this guy outside. So we need storage block as well. So for that I'm going to create a list. Left max is equal to into, let's store the length of height in a variable. Let's say size is equal to length of height, so that we don't need to keep calling the length function and again. So 0 into size, and then right max is equal to 0 multiplied by size. What I'm doing here is I'm creating a list and I'm defaulting all the values in the list to be 0. Now we are going to find the left max. For that, let's write a command. max and fill the list. We are going to iterate over the elements for I in range of 1 comma size, and then here we can default the left max 0th element with height of 0, and then here we are going to compare from the first element. Now left max of I is equal to max of left max of I minus 1 comma height of I. So what we are doing here is we are comparing the maximum of the previous element with the current element, and then we are inserting that value inside the list. Similarly for the right side, find the right max and fill the list. So right max of size minus 1 is equal to height of size, which is going to be the last element, size minus 1. And then for I in range of n minus 2 comma minus 1 comma minus 1. So sorry, size minus 2 comma minus 1 comma minus 1. So what I'm doing here is I'm going to iterate through the array in a reverse direction. So I'm taking the size, which is the end of the array, and then iterating backwards until minus 1. So minus 1 is not inclusive, so we are going to go till 0, and then we are going to decrement by minus 1. Here we are going to right max is equal to right max of right max I plus 1 comma height of height. So now we have found out the right max as well, and then we have fill the list. So let's go inside our actual iteration. So here we have done all these things. So we have completely eliminated these two for loops here. So now the for loop is going to remain the same, and then here we can replace it with the size which we have used. Okay. And then blocks of water is equal to blocks of water plus min of left max of I, right max of I, and then minus height of I. That should return the blocks of water. So let's run this solution. Okay, int object is not iteratable. So where is the error? So right max of I plus 1. So here we have to specify right max of I, which we have missed. And then 6. That's cool. So this solution is going to run on time complexity of O of n and space complexity of O of n, because we are using two arrays, one for the left max and one for the right max, which is 2n, and which is nothing but basically O of n space complexity. And by compromising on the space complexity, we have reduced the time complexity from O of n square to O of n. Now for the third solution, we need to go back to this graph. So now what we are going to do is we are going to use the two variable approach. We are going to have a variable to determine the start of the array and a variable to determine the end of the array. And then we are going to keep moving both the variables inward, and then once it reaches the common element, we are going to stop iterating there. So for example, let's say that we are iterating from the leftmost and your start is going to be on the left and the end is going to be on the right, and then first you are going to compare the elements. So now the start is greater than equal to the end, which is true. So here we are not going to achieve anything, so we are going to subtract the end by -1. So now we are going to compare the left and the right, and the left is smaller. So let's go into the left. This left element is less than the left max. So there are going to be 4 variables here: left, left max, right, and right max. It would be kind of confusing, but I would make it as simple. So here the left is going to be block 1, and we have initialized the left max as 0. So now the left is not less than the left max. So we need to increase the left max to the current element. So that left max is now 1 and the right max is still 0 since we have not updated it. And then we increment the left by 1. So now we come to the second block. And now we know that the left max is 1 and the left value is 0. So when we find out the difference between these two, we are going to have a difference of 1, which means that we can store a block of water here. So let's start implementing this solution. Okay, so we don't need the additional lists here, which cause the space complexity to increase. So let's remove those blocks, and then we are going to add 4 variables now. So the first one is going to be left, which is 0, which means that the start of the array, and then left max, which is also going to be initialized to 0, and then right, which is going to be size -1, which is going to point to the end of the array, and then right max, which is going to be initialized to 0. So now we need to iterate over the blocks. In this solution we are going to use while block, while left is less than equal to the right, because we are going to iterate from the left side of the array as well as the right side of the array, so we don't want to continue after they have crossed each other, and we might not need this for loop anymore. So let's remove this one, and then this is going to be the return block of water. Okay, so now we are going to check if height of left is less than height of right, and then we are going to have a else block for it. So here, if this is true, then what we are going to do is if height of left is greater than left max. So if it is greater than the left of max, then we need to increment the left max. Left max is equal to height of left. If it is not the case, then we are going to add the result. So blocks of water is equal to blocks of water plus left max minus height of left. Similarly, here we are going to check the same, and we have to increment the left variable now. Left equal to left plus 1. So we are iterating to the right side, and now in this else block we are going to do almost the same. If height of right is greater than right max, then we are going to have right max is equal to height of right, else we are going to have blocks of water plus right max minus height of right, and then here we have to subtract 1 from the right so that we would be iterating towards the left side. And once we are done with this while loop, we should be returning the blocks of water. Now let's run the solution and then see what happens. And we got a 6, the expected answer. So now the time complexity has reduced. It's not reduced, it's like the same O of n, because we are iterating over the array of elements only once, but we have completely eliminated the space complexity. We don't need any additional list or any other data type structures to store the elements. So by reducing the time complexity from our first solution from O of n squared to O of n, and from our second solution which had a space complexity of O of n, is also eliminated in this solution. So this is the best optimized solution for this problem. Thank you for watching this video. If you like to see more LeetCode solutions, then please subscribe to this channel. Thank you. Bye bye.